We're going to talk about solving quadratics. This is a quadratic. Now, this is actually a parabola. And a parabola is what we call the graph of a quadratic. So when it is graphed, we call it a parabola. When it's written like this, when it's written in algebra, we call it a quadratic equation. Okay? So the parabola is the picture. It's the graph. The quadratic equation is the algebra that makes the graph. They're called two different things, and we need to be clear on that. Now, there's a couple of things that you learned in grade 10 that we really need to remember. Such things as, what is a y-intercept? Well, a y-intercept is where we cross the y-axis. So this is your y-intercept. And in this case, it's going to be -1, -2, -3, -4, -5, -6. So the y value is -6, and the x value is 0. Okay? So if I'm going to have a y-intercept, I have to be on the y-axis, which means that my x value has to be 0. Now my x-intercepts. These are my x-intercepts. There's one there, and there's one there for this particular parabola. And they are at 6, 0, and -2, 0. Notice that the y value is 0. If I'm going to be on the x-axis, that means I can't have any y movement. I can't go up or down off of the x-axis. The vertex. The vertex is the place where it changes direction. So this is decreasing, 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 and then it starts to increase, 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 increase as we move left to right. So the vertex in this particular case is the lowest point of this parabola because this particular parabola opens up. But that is your vertex, and it is at the coordinates 2, so 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. -8. The axis of symmetry. The axis of symmetry is the line that cuts the parabola directly in half, symmetrically. So this is your axis of symmetry. Right there. Okay? Notice that the vertex lies on your axis of symmetry. This value will always be the axis of symmetry, whatever the x value is in the vertex. So this lies halfway between the x-intercepts. So the axis of symmetry lies directly halfway between this x-intercept and this x-intercept. Okay, so it's exactly halfway between there. And notice the vertex lies on the axis of symmetry. Such that this value of x is always the axis of symmetry. Now for this one, the direction of opening is up. Because the direction of opening is up, this vertex gives you a minimum value. Every other point on the parabola is higher than this point. So it opens up, therefore vertex gives a minimum point. Okay. In this case, what is the max or minimum? Well, we've got a minimum, and its value is -5, -6, -7, -8. So notice the vertex, its x value is the axis of symmetry, and its y value is the max or minimum value. Now we have two new words to talk about, domain and range. Domain means all the possible values of x that could go into this equation, that have a place on this graph. So if I look at all the possible values of x, it's going to be every single value in this direction and every single value in this direction. What that means is every single value of x has a corresponding position on this curve. Every single value of x. As this parabola keeps moving up and up and up, it keeps using up all the different values of x. So how do we say that the domain is all the possible numbers on a number line? We say that x is an element of the real numbers. And you watched your videos over the weekend, so that makes sense to you. These are all of the real numbers. No complex numbers, but every other number that you know about. Now the range. The range are all the possible y values. Well, this parabola doesn't go below -8. So all the possible y values that this parabola can have is anything greater than or equal to -8. How do we say that? We say y must be greater than or equal to -8, and we say y is also a member of the real numbers. We'll do more work with domain and range, but this is a first step at talking about it. Okay. Solving quadratics by factoring. Solving a quadratic means finding the value or values of x that make the equation equal to 0. So on a graph, solving a quadratic means finding all the values of x that make the equation 0. That's here and here. So on a graph, solving a quadratic means finding the x-intercepts.
Sir.
Yeah?
Are you writing on the paper?
I am.
Okay. Well, I think my screen's just frozen. Like, I can hear you, but I can't see anything you're doing.
That's not good. I'll try refreshing mine, but...
Okay. I can just leave and join right back.
Might be an idea. Yeah.
Okay. I'll be right back.
Anyone else having the same problem? No? Okay. So let's think about this for a minute. If I have a quadratic equation that looks like this, y equals ax squared plus bx plus c, and if I want to set that equal to 0, if I'm setting y equal to 0, what I'm finding is the places where the parabola crosses the x-axis, because these are the places where y equals 0. So if I had a equation, then I'm going to have to use algebra. And if I have a graph, then I can just read it. So if I'm going to find the solutions to this one, you would say the values of x that make y equals 0 are, and here's one of them. So it's -1, -2, -3. And here's another one. It's x equals 1. Those are the values that make y equal to 0. Well, if I do this using algebra, we're going to make use of the 0 principle. You're going to say either the first one equals 0 or the second one equals 0. Now, you've been doing this with restrictions, but this is different because this is allowing it to equal 0 now. It's not does not equal 0. We're going to solve for x. We're going to get x equals 5. We're going to solve for x, and we're going to get x equals 3 over 4. Now, if we take a look at Desmos, if I call Desmos up now, let's do that. And if I put in the question that we just did, which was bracket x minus 5, end bracket 4x minus 3, end bracket, and just to make it look pretty, I'll do y equals. And what I'm going to do is I'm going to come out a little bit. So there's my parabola. This is the algebra we were looking at. These are the x-intercepts. One is at 0.75, and the other one is at 5, 0. Well, what we came up with for answers was 5 and 3 divided by 4. Well, 3 divided by 4 is 0.75. So this is the algebra that makes this parabola. We could also take a look at a table of values for this. And if I wanted to come up with the values here that gave me 0, I think I can just, no, I can't. I can only put in values of x. That's interesting. Okay. I could, yeah, that's about it. All right, I'd have to look on here. Those are my 2 zeros. Okay. Let's look at the next question. So we're going to focus on solving equations algebraically. So this says state the roots of each of the following. We should really clarify now that roots mean the zeros, which also mean the solutions. So when I say roots, another word for that is zeros, another word for that is the solutions, and basically what it means is what values of x will make this equation equal to 0. That's basically what it says. So whenever you see the word roots, it means zeros, that means solutions, and basically it's saying what values of x is going to make this whole thing equal to 0. Okay. This can't be solved easily. You can't take the 9 over to the other side and try to solve for x. It's not going to work. Let me show you what lots of kids do. Lots of kids do this. They do x squared plus 6x plus 9 equals 0. They do x squared plus 6x equals negative 9. They do x bracket x plus 6 equals negative 9. And then they try to tell me that either x equals negative 9 or x plus 6 equals negative 9, which is a big fat lie. It's just not true. If two numbers multiply to give negative 9, they could be any such numbers at all. They could be decimals, they could be 3 times 3, they could be 1 times 9. it goes on and on and on. This is not the zero principle. The zero principle is two things multiplied to give zero. That's why it's called the zero principle. So to do the zero principle on this, we must factor this to equal 0, not 9. So I'm looking for two numbers that multiply to give 9 and add to give 6. I'm thinking 3 and 3. So this will be x plus 3 equals 0. So this will be x equals -3. So this, the solution for this, the root for this is x equals -3. And in fact, there's two -3's there, aren't there? There's x equals -3 and x equals -3. We don't like to write this because that's kind of like repeating yourself. It's kind of like mathematically stuttering. So we're just going to write the one time. But notice that we will say that we have two identical, I don't think I spelled identical wrong. Maybe I did. Identical, two identical real, as in real numbers, roots. Even though we're going to say the answer is x equals -3, it's understood that there were actually two factors up here. Let's do this one. Now remember, we're using the zero principle. We have to get this equal to 0. So it has to be rearranged. You have to make it equal to 0 first. It must be in the form ax squared plus bx plus c equals 0. Okay, it has to be. So now we're looking for two numbers that multiply to give -60, add to give 11. Well, I don't know what it is offhand, so 60 is 1 and 60, 2 and 30, 3 and 20, 4 and 15. 4 and 15 will work. And it's going to be -4 and +15. So I'm going to use another piece of paper, and I'm going to do my factoring. So it's going to be 6x all over top of 6, -4 and 15. I can common factor a 2 out of here. I can common factor a 3 out of here. Two times 3 will reduce with the 6 on the bottom. So that's going to leave me with 3x minus 2. 2x plus 5 equals 0. Notice I don't want to see the factoring in here. I just want to see the factors. I want you to go from this to the factors. Then you're going to say either 3x minus 2 equals 0 or 2x plus 5 equals 0, because that's the zero principle, right? I've got two things, a and b, equaling 0. So either the first one 0 or the second one 0. Solving for x, 3x equals 2, x equals 2 over 3, and this one is 2x equals x equals -5 over 2. So basically all we're doing is factoring again. So this one, 5x squared minus 25.
So you're just letting it go with 9.
Oh, thank you. Okay,
Cool.
we can take our break now. We'll take our, let me stop the video.